Lesson 8, Group 4, partial fractions with linear or quadratic factors that are repeated. Example number 8, you have s cubed plus 4s squared plus 20s minus 7 over s minus 1 in bracket square, then s squared plus 8 in bracket. The first factor is linear and it is repeated. The second factor is quadratic, but it is not repeated. So you have the given compound fraction. In the first factor, you have s minus 1 to the power of 1, which you assign one numerator before s minus 1 to the power of 2, another numerator in this form. The quadratic factor is assigned a linear factor in the numerator, cs plus d. You find the LCM and simplify. You have this result multiplied through by the LCM. You have the resulting equation P. If you check very well, we have first term, second term, third term. The first term and third term in the right hand side, both terms have s minus 1 in common. So it is possible to turn the first and third terms to 0 by putting s equal to 1 in equation P. This is equation P. You put s equal to 1. When you simplify, you have this result. First term, third term, the two terms will turn to 0. You are left with the left hand side that is equal to 18 and 9b. So 18 is equal to 9b. Divide both sides by 9 and b is equal to 2. Since we are able to find only b at this point, we cannot use the alternative method of letting s assume certain values except the ones used previously. In equation P, we have 4 constants, a, b, c, and d. We are able to find only b at this point. We cannot use the alternative method. The only approach is to expand equation P. If you carry out the first set of expansion, you have this result. Next, you open this bracket with a, you have this result, plus bs squared plus 8b. You use cs plus d to multiply this term. You have cs cubed minus 2cs squared plus cs. The same term now, using d part of it to multiply this term, you have this result. Next is to bring together terms with the same power of s. You have this and this. If you factor out s cube, you have this result. The power of 2 for s, one term is here, another one is here. You have this and this. If you bring them together and factor out s square, you have this result, follows by this and the constant terms. Comparing and equating the coefficient of s cube, s square, s, and the constant terms, we have the following equations. There is s cube here. The coefficient is 1. Therefore, a plus c is equal to 1. If you compare this term, you have s squared here. The coefficient is 4. So you have that term equal to 4. If you compare terms with s, here the coefficient is 20. You have this as equation 3. If you compare the constant terms, you have this equal to minus 7 in this form. The 4 equations need to be rearranged until we have 2 equations with the same variables that can be solved simultaneously, noting that previously b is equal to 2. You have to note that. If you set targets on 2 variables you wish to arrive at, the rearrangement becomes very easy. Since b is equal to 2, let our target variables be a and d. So from equation 4, this is equation 4, you simply replace b with 2. You have this result. So you have minus 8a plus d. This term is 16. You transfer it to the right hand side and you have minus 8a plus d equal to minus 23 as equation 5. Let's consider equation 1, a plus c equal to 1. Let's make c the subject and we have equation 6. To continue, you have to replace equation 6 in equation 3. This is equation 3. We are replacing c with 1 minus a. In this form, you have 8a minus a, that is 7a minus 2d equal to 20 minus 1. You transfer plus 1 to the right hand side and you have 7a minus 2d equal to 19, equation 7. Now, equations 5 and 7 both have the same variables. Hence, you can solve them simultaneously using elimination method. You have both equations. I wish to eliminate variable d. To achieve that, the coefficients must be the same in both equations. Here you have 1, here is 2. To achieve 2, you multiply equation 5 by 2 and equation 7 by 1. So equation 5 becomes minus 16a plus 2d equal to minus 46. Equation 7 remains the same. The coefficients are not the same. I need to add because the signs are opposite in both equations. So if you add, you have minus 16a plus 7a, that is minus 9a, plus 2d minus 2d equal to 0, minus 46 plus 19 is minus 27. You have these results. To get a, divide both sides by minus 9. A becomes 3. To continue, replace a with 3 in equation 5 to get d. This is equation 5. You replace a with 3, you have d equal to minus 23 plus 24. This term is minus 24. If you transfer it, it becomes plus 24. When you subtract, d is equal to 1. C is remaining. Let's use equation 6. This is equation 6. C equal to 1 minus A. A is equal to 3. So C becomes 1 minus 3 and C is equal to minus 2. Therefore, you have all the results. Thus, you have the given compound fraction that is equal to the partial fractions. You simply replace A, B, C, and D with what they stand for. You have this result. Here, since 1 is positive, you can write 1 first, then minus 2 follows in this form. This is the required partial fractions. End of lesson 8. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.